So today we're going to talk about properties of rational exponents and radicals, which is really just more practice of things we've already done and a little bit of friendly advice of other ways to proceed through things. So my first example is solving via reciprocal exponents. So we're going to solve 5x cubed equals 1080. Well, the first thing we need to do is get x cubed alone. So we divide both sides by 5 and get x cubed equals 216. Now, you could certainly think about how to undo cubing by cube rooting, and that works. But I would like you to also think about reciprocal exponents, because in tougher cases they'll be more handy, and they mean the same thing. Great review and practice of our fraction exponents meaning roots. So, what I'd like you to do here is think about what number would I multiply 3 by to make it 1? Because if I can make that 3 a 1, then I've got x to the first, which is getting x alone. Well, the reciprocal always gives me a 1 when multiplying. So if I take 3 and I multiply it by 1/3, so essentially I take x cubed and raise it to the 1/3, then I'll end up with x to the first. What I do to one side of an equation, I have to do to the other. So I also raise 216 to the 1/3. Well, those go away, so I have x equals the cubed root of 216. And the cubed root of 216 is 6. So again, just another way of thinking about how to solve equations with exponents on the variable. The other thing we need to do today is review and learn a little bit more about simplifying radicals. First, the review. If I ask you to simplify the square root of 20, you need to think of the largest perfect square number that goes into 20, and in this case that would be 4, and you break up 20 into that perfect square number times the leftovers. 4 times 5 is 20. You know that the square root of 4 is 2. We cannot square root 5. So when we simplify the square root of 20, we get 2 root 5. Similarly, I might ask you to simplify the cubed root of 16. Well, you need to find the perfect cube number that goes into 16 nicely, and that would be 8. So this is the cubed root of 8 times the cubed root of 2. The cubed root of 8 is 2. I cannot take the cubed root of 2, so I would leave that alone. So keep in mind, regardless of what your index is or what root you're dealing with, math is consistent. Always find the largest perfect cube or square or fifth or whatever that divides into your number and then break it apart. Now sometimes in problems like number 2, we have to do a little bit more. So the first thing I'm going to do here is recognize that these are both cubed roots, and so I'm going to use my property from the other day and put this all underneath one fraction. So this is really the cubed root of 5/4. Well, again, I can never have a radical of any kind, square root, cubed root, whatever, in the bottom of a fraction, in the denominator. So I need to figure out how to make that go away. When it's a nice monomial, you just figure out the next perfect number that it'll go into. So in this case, this is a cubed root. So I need to figure out what's the next largest perfect cube number that I can make this easily. Well, 4 goes into 8, and the cubed root of 8 is perfect, as we saw over here. So if I could take 4 and multiply it by 2, it'll become 8, which makes it a perfect cube. But what I do to the bottom of a fraction, I must do to the top. So now I have the cubed root of 10 over 8. Well, the cubed root of 10 I don't know, so I leave that alone. The cubed root of 8 I know is 2, so I clean that up. I've gotten rid of the radical in the denominator of my fraction, and I've cleaned up the rest. Again, math is consistent. That will work with any kind of radical you encounter, whether it's a square root or a cubed root or a 17th root. Finally, in example 3, it's a little more complicated in that I have a binomial with a radical in it in the denominator. But we've already talked about conjugates with our complex numbers, and conjugates always get rid of radicals. Square root of -1 is I, and that's when we first talked about conjugates, so we're being consistent again because this is also a square root. So in order to get rid of a square root that's within a binomial in the denominator of a fraction, we multiply both the bottom and the top by the conjugate of the bottom. So here I have 3 minus root 2. The conjugate is 3 plus root 2. What I do to the bottom of a fraction, I must do to the top. And then we clean it up. So we distribute this 5 through. 5 times 3 is 15. 5 times root 2 is 5 root 2. On the bottom, I double distribute, but keep in mind the whole point of the conjugate is that those middle terms cancel. So 3 times 3 here is 9. If you want to be reminded, 3 times root 2 is positive 3 root 2. Negative root 2 times 3 is negative 3 root 2. Those always cancel, so don't waste your time with them anymore. Negative times positive is negative. Root 2 times root 2 is 2. Keep in mind, when we multiply a square root by itself, it's as though you're squaring it, so the squaring cancels out that square rooting. Knowing these little properties will save you a ton of time. So now we clean up that bottom, and we have 15 plus 5 root 2 all over 7. That's it. Not too much that's new, just nice practice and little hints and tips to make your life a little easier. Have a great night.